So next theorem is intermediate value theorem. What are the hypotheses if f is continuous on AB and f? Now, by the way, it really, this is sort of tricky to write. Your book writes this in words. Y0 is between f of A and f of B. That's because it's not necessarily true that f of A is less than f of B. So really this should say or f of B is less than Y0 is less than f of A. Right, but I didn't want to overcomplicate that. But basically it's saying that Y0 is between f of A and f of B, but f of A could be over here. The f of A and f of B could switch. Okay, but we won't worry too much about that. The hypotheses are f is continuous on AB. So that means that if you're going to use, as we've mentioned before, if you're going to use intermediate value theorem, you have to establish that f is continuous. Remember, they could tell you f is differentiable, and then because differentiability implies continuity, you would conclude f is continuous, but you need to state that. Okay, so f is continuous, and f of A is less than Y0 is less than f of B. Basically, Y0 is between f of A and f of B. Okay, then conclusion is there exists C in AB such that f of C equals Y0. Okay, it's really useful to have a picture of this one, especially because it makes more sense, I think, as a picture. So we have our points A and B, and because I've written f of A is less than f of B, that means that f of A is less than f of B. But of course, these could be switched. That's what complicates this statement. All right, so but then the function, can do anything it wants in there. Then here's f of A over here, f of A, and here's f of B. So then the critical thing about Y0 is that Y0 is a point that is in between f of A and f of B. Then the point C is a point where f of C is equal to Y0. So that's our C right there, C. Maybe use a different color for C. Yeah. Okay, so that's what the intermediate value theorem looks like. It says we can't get from here to here without crossing Y0 somewhere, and wherever we cross it, that's what the C is. All right, so in words, a function cannot pass from, I should say continuous function, from one value to another without passing all points in between. All right. Now you could think of different ways to say that. That's just one way that I think of to say it. That's how I think of it. You can't get from f of A to f of B without crossing everything in between. Okay. And then extreme value theorem, hypotheses, f is continuous on AB, conclusion, f attains a global minimum and a global maximum on AB. Okay, so hypotheses, f continuous on AB. By the way, the word attains is specific in mathematics. It means that f has that as a value, has these things as values of the function. So what I mean by attains a global minimum maximum. All right, so our conclusion is f attains global within the context of that interval, global max and min on the closed interval AB. Okay, so the picture is we have some point, well, let's draw the function first. So we have a function, it does whatever, whatever, who knows what it does. By the way, this one doesn't require differentiability, neither does that. So let's throw a non-differentiable point in there just for kicks, right? And then we can have A wherever and B wherever. All right, then there have to be maxes and mins. So no matter how I drew that, I just randomly drew that. So here's, I guess that looks like the global min, and here's what looks like the global max, right? So in words, every continuous function, I'll say that this time, function attains, really at least, because it could have more than one, at least one global min and max on any closed interval. Okay. Yeah, maybe I should mention at some point. It's worth mentioning that if a function, on an interval or on the whole real line, either way, if a function has a bunch of equal maxima, right? Let's say that those are all the same y value up here. All right, those are all global maxes. So you have 4 global maxes. So basically what I'm saying is you can have more than one global max and you can have more than one global min. Same with the mins, right? So here we have 1, 2, 3, 4, 5 global mins. Well, I guess this point throws a monkey wrench in the works because then this is the global min and none of these are. But let's say that the interval ends right there. Then you have 1, 2, 3, 4 global mins. 4 global mins. So just to get you the idea that there isn't necessarily just one global max, global min. Okay, so this is an overview of theorems. The AP exam expects you to know the theorems and the names of the theorems. You have to call on them by name and know the hypotheses of each theorem. So you need to know the names of these theorems and know their hypotheses.